This video is about the slope-intercept equation of a line. So when we have a line, so let's say we have this line here, we know that we can always write an equation for that line. So actually the equation for this line is y equals 2x minus 1. Now, this equation would help us describe every point on this line. So let's say we wanted to find a point, well, a lot of times you'll see it written as this. This is kind of what we call kind of more function notation. There's some similar problems similar to this on your quiz. And so maybe we would try to figure out, well, what is, and you might see it written like this, f of 3. Basically, that is all we're doing is figuring out when x is 3, what does y equal? And so what we do is we plug in 3 for x, and we evaluate, or we simplify using our order of operations, or PEMDAS. So we know that it's, well, 2 times 3 is 6, bring down the minus 1, 6 minus 1 is 5. So for this graph, that tells us that the point, when x is 3, y is 5, so 3, 5 will be on our graph. So I would go over 3 and up 5, and be right about here, and it's on our graph. We can plug in any x value we want and get the matching y value on our graph. Slope-intercept form has 2 parts to it. It has the slope and it has the intercept. So you often see it written as y equals mx plus b, where the slope is m and the y-intercept is b. So in our case, for our equation, y equals 2x minus 1, our slope is 2, our y-intercept is negative 1. So we just plug those into y equals mx plus b. We leave the y equals, we replace the m, we leave the x in the plus, and replace the b. Let's do some more examples. All right, let's look at this example. Here we want to write the slope-intercept equation of the line. So I have the line written there. I have 2 points on the line. That helps us to find our slope. So when we're trying to find these, let's do that. Let's see, step 1. Let's find the slope. Now, you could count. You could start at the top point and go to the second point. So start up here at 0, 4. We know we can go down 1, over 1, 2. And that's going to give us on our point. So that would tell us our slope would be negative 1 over 2. Or we can always plug it into our formula, like in my last video. So this would be x1, y1. This is x2, y2. And we plug in our slope formula, m equals y2 minus y1 over x2 minus x1. And so we're doing 3 is y2 minus 4, because that's our y1. Our x2 is 2, our x1 is 0. So we have 3 minus 4, which gives us negative 1, 2 minus 0, which gives us 2. So our slope is negative 1 over 2. Now, our y-intercept, this one's actually a fun one. So let's see, step 2, find the y-intercept. Now, this is where the line crosses the y-axis. So here, that point is going to be right there at 0, negative 4. We just need the y-coordinate for it. So in our case, we just need 4. So our y-intercept, or b, equals 4. Step 3, right, as an equation. So when we do this, we know y-intercept form is y equals mx plus b. We're going to rewrite this. We're going to rewrite the y. We're going to rewrite the equals. Our m, we're going to put our slope. We write our x there. Our b, we rewrite our y-intercept. So this line right here of y equals negative 1/2 x plus 4 would be the equation in slope-intercept form of this graph. Means some problems you might see in this section include graphing an equation in slope-intercept form. Here we have an example. We're going to graph y equals 2x minus 3. First thing we want to do, step 1, is plot the y-intercept. Now here our y-intercept is negative 3. So it's this part right here. Because it's this minus before the 3, it's going to be a negative 3. So we go to our graph, and what we're going to do is go down to negative 3 on our y-axis and make a dot. Step 2, we're going to use our slope to plot a second point. Now, we know our slope is 2. That means our rise is 2. Our run is 1, right? Because m2 is the same thing as saying 2 over 1. We're allowed to do that. So what we're going to do, we're going to go from our point, our y-intercept, and we're going to go up 2 over 1 and make a dot. And let's go ahead and do another one. Up 2 over 1. Make another dot. Connect those dots. Actually, that's what step 3 is. Connect the dots. That is going to be the graph of the line, y equals 2x minus 3. Sometimes we'll be given a line, and we want to figure out what is the slope-intercept equation of this line. So in this case, we don't have any points listed on our line. We're going to figure out some points. So what I like to do, first thing, is figure out, find the y-intercept. So in our case, this is where it crosses, where the line crosses the x-axis, or the y-axis. That is going to be our y-intercept. So if we look right here where it crosses the y-axis, that is going to be right there at 1. So that means b equals 1. Now, from this point, figure out the slope. What I like to do is count up or count down. So in this case, we have a positive slope. So if we start from our y-intercept and we go up, let's see, I'm looking for a point that's nice and pretty, kind of on a grid. Let's go to this one right here. If we go up 2 over 1, we get to that point, and that point is on our red line. And so we went up 2 over 1. That tells us our slope, m is 2 over 1, which is just 2. You can also do this by finding, I know it's easier when you're looking at the computer because you have grids, and so it's easier to tell the points, but if you look closely, like this point is actually, let's see, 1, 3, and this point right here is going to be 0, 1. So you can use your slope formula, like we've previously done, to figure out what our slope is going to be. We know our slope formula is y2 minus y1 over x2 minus x1. Doesn't matter which point you let be x1, y1. Here I labeled them on our graph. So when we subtract here, let's see, y2, so let's see, that's 3, y1 is 1, x2 is 1, x1 is 0. 3 minus 1 is 2. 1 minus 0 is 1. So that gives us our slope is 2. So we figured out our y-intercept. We figured out our slope. Our last step, we want to plug our slope and our y-intercept into y equals mx plus b. So y stays the same, equals stay the same. The m, that is our slope, which in our case is 2. Keep the x with it, plus our b, it crosses at 1, so our b is 1. So y equals 2x plus 1 is the graph of this line. All right, let's consider a real-life situation on when we would maybe see slope-intercept equations. So we have an example here where Peyton was given some money for her birthday. She puts that money into a bank account. Each week after that, she deposits the same amount of money into her account. We can actually write an equation that models this. Let's say in our case, the equation is y equals 10x plus 25. In our case, y is going to be the amount of money in the account, and x is going to be the number of deposits, or like the number of weeks that she deposits money into her account. Now, when we look at this, we have our equation y equals 10x plus 25. The 25 is going to represent the y-intercept. This tells us that for her birthday, Peyton was given $25. And that's the original money that she started out and deposited into her bank account. Then each week, she put $10 in there. That is our slope. So our slope here tells us that Peyton put $10 into her account each week. So, slope-intercept form, our equation is going to be y equals 10x plus 25. Y would be the amount of money in the account after X number of weeks. So we could actually plug in, let's say we wanted to figure out if she deposits $10 a week into her paycheck or into her account after 5 weeks, how much money would she have? To do this, actually, we'll do this example on the next slide. All right, so let's continue with the previous example. So here we had that equation, y equals 10x plus 25. That represented the money in Peyton's account. So we know the starting amount was $25, and she put $10 into her paycheck each week. So let's say we wanted to figure out how much money would Peyton have in her account after 5 years. Or we're dealing with weeks. After 5 weeks. So that just means we're going to figure out what does y equal when x equals 5. So we're going to say, all right, plug in 5 there. So we do 10 times 5, which we know is 50. 50 plus the original 25 gives us 75. So that tells us our y is going to equal $75, or Peyton would have $75 in her bank account after 5 weeks. Sometimes you may see examples written like this, where it says, if f of x equals 3x minus 10, what is f of 2? All this means is that we're trying to figure out, it's very similar to y equals 3x minus 10, but we're plugging in when x is 2, what is y? Pretty much what we're trying to figure out. So the way we do this, say, all right, well, f of 2 equals 3 times 2 minus 10. We know 3 times 2 is 6. Bring down our minus 10. 6 minus 10 gives us negative 4. So that means f of 2 is going to equal negative 4. So when x is 2, y equals negative 4. That's what that means.